folks, welcome back to example 3. So we're going to add another level to this. Now we're going to add the negative exponent. All right, so you see the m over n. We still have the rational exponent, but now we have this negative. And maybe you've dealt with negative exponents before, maybe you haven't. I call it the traveling exponent. I don't think anyone else does. But what this reminds me is if I see a negative exponent, right? If something's in a numerator, I'm going to move it to a denominator. If something's in a denominator, I'm going to move it back up to a numerator. So I think of things travel. Things travel from numerator to denominator. And once I travel it, right, if you'll see over here on this equal sign, right, a to the negative m over n. It's technically in a numerator right now because I could always write it as itself over the number 1. And I'm going to move this term down to the denominator, right? I'm going to move this and it's going to become 1 over a to the m over n. But I want you to see, once I moved it from numerator down here to denominator, take note that I didn't write the negative anymore. So once you do the traveling, you no longer need to write the negative. So just to give you an idea, let's take a look at a couple of side examples without the rational aspect to it. Let's just think of x to the negative 2. If I wanted to travel that, right, I see the negative exponent, I'm like, oh, it's time to head down to a denominator. And I say down to a denominator because this is technically, if I wrote it as a fraction, x to the negative 2 is in a numerator right now. So what I'm going to do is I'm going to rewrite that as 1 over x squared, right? I'm going to travel it down. So x to the negative 2 is 1 over x squared. And take note, here I had the negative symbol, and once I traveled it, I no longer had the negative symbol, right? So if I see something like x to the negative 3, that's 1 over x cubed, right? And then on the flip of it, let me go ahead and show you. I'll keep making little separations here. Let's say I had 1 over x to the negative 2. So you see my negative exponent is in a denominator. Then I need to travel it back up to a numerator, and that's just going to become x squared. But as soon as I traveled, right, numerator to denominator, numerator to denominator, denominator up to numerator, you can see I stopped writing the negative exponent. Okay? All right. So we're gonna mess around with that. So we're gonna now take a look at traveling exponents, combo that with rational exponents, and see where we get. All right, so if I look at this, 36 to the negative 3 halves, I see my negative, and I go, okay, let me go ahead and travel it. This is technically in a numerator right now because I could think of this as a fraction, 36 to the 1 half, 36 to the negative 3 halves over 1. So I'm gonna make this 1 over 36 to the 3 halves. All right, so once I've done that, then this denominator takes us back to example 2. I'm just gonna erase this right now so I have a little bit more space. So then I'm gonna think about, okay, I've got that rational exponent, but I'd like to handle this when my numerator is just 1, right? Because it's 36 to the 3 halves. It'd be easier, or it'd be more effective if I just did it as 36 to the 1 half cubed. So what I mean is I'm going to rewrite this as 36 to the 1 half, right? And then I'm going to cube it. I'm going to split that fraction so I have a fraction with 1 over my denominator, and then I'll use that next exponent with a number for my numerator, right? So instead of 3 halves, I'm going to do 1 half cubed because 3 times 1 half does get me back to 3 halves. And then, right, once we're here, we're going to rewrite this as a radical. So we're going to go between rational exponents and radicals. So as I do this, this is going to be 1 over, this is going to be the square root of 36 cubed, right? And I think I got to scooch this up just a bit or we're going to not be able to see it. Let me do that. All right, and when I do 1 over the square root of 36 cubed, well, square root of 36 is 6, so this is 1 over 6 cubed. And depending on how well you know your cubes, this is the number 1 over 216. So 6 cubed itself is 1 over 216. But if I kind of just take a step back, when I see that negative exponent, right, I know I'm going to have a fraction at the end because that's what the rational or the negative exponent is doing. You're reciprocating fractions. So anything in a numerator goes to a denominator. Anything in a denominator goes to a numerator. And I can see I didn't have a fraction to start, but with that negative exponent, I'm going to. All right, so let's take a look at 32 to the negative 4/5. So I see the negative and I go, all right, I'm going to rewrite this as 1 over 32 to the 4/5. And the thing is, I have that rational exponent, And the numerator as of right now is 4. And I'd really like it to be 1. So let's rewrite this. This is going to be 1 over, and I'm going to do 32 to the 1/5. And then I'm going to need to raise that to the 4th power. Right? So that's how we split up those rational exponents when the numerator isn't 1. We rewrite it with a fraction, a rational exponent where the numerator is 1. Right? And then we take into account that original numerator as our next exponent. All right, so then now I'm looking at 1 over 32 to the 1/5, right? The 5 becomes the index. I'm going to rewrite that as a radical, and I'm still going to raise it to the 4th power. Right? And depending on how much we remember about the 5th root of 32, maybe you have that committed to memory, maybe you haven't yet. Let me just put a little separation here so we can see it. So this is going to be 1 over, all right, so I have something to the 4th. This is going to be the 5th root of 2 to the 5th. Those are going to cancel. It's going to leave me with a 2 to the 4th on that denominator. And 2 to the 4th is 16, so my end game answer is 1 over 16. Okay? All right, so let's look at C. Because C starts with a fraction, right, and a negative exponent. So when you see a fraction, an entire fraction with a negative exponent, what you do is you take the reciprocal. And once I take the reciprocal, I no longer write the negative symbol, right? Just like here, once I traveled from numerator to denominator, negative exponent, I didn't need it anymore, right? Here, I had a negative exponent. Once I traveled it, I didn't need it anymore. So what I'm going to do here is I'm going to take the 4, move it to the denominator, the 9, move it back up to the numerator, and then I'm going to stop writing the negative exponent. So this is going to become 9/4 to the positive 5/2. Because once you reciprocate, right, once you've done that traveling, you've handled the negative. So at this point, I'm like, all right, I can handle this. I'm going to rewrite this rational exponent as 9/4 to the 1/2. And then I'm going to raise it to the 5th power. Okay? And as we're going along with this, right now I've got my fraction 1 over a number. Whatever that denominator is, that's my index. So I'm ultimately going to take the square root of 9/4. Whatever that is, I'm going to raise it to the 5th. So let's go ahead. I still have this thing to the 5th. And now I need to look at the square root of 9/4. Well, we can distribute radicals over division. So this becomes the square root of 9 over the square root of 4. All right, so let's rewrite that. I still have something to the 5th, but it is the square root of 9 over the square root of 4. Oops, let me write to the 5th. All right, well, we know the square root of 9. This is 3. We know the square root of 4. That's 2. So now I'm looking at 3/2 to the 5th. All right, and this, again, comes back to how much do we know, or how much do we remember about our 5th powers. And the 5th ones are a little harder to remember, but 3 to the 5th is, and I'll just write this as 3 to the 5th over 2 to the 5th. So we've got 3 to the 5th is 243. 2 to the 5th is a little bit more familiar to me. I do remember that 2 to the 5th is 32. So that is my end game answer. And just so you can see it on your calculator, because I want you to see you could try all of these on your calculator. What I could do is I could say, hey, calculator, can you please do 4/9 in parentheses, raised to the, and I need to put this entire fraction in parentheses also, negative 5/2. All right, when I do all of that, I'm going to hit enter, and I'm going to get a decimal. And then I'm going to do math frac. So I do 4/9 raised to the, in parentheses, negative 5/2. All right, when I hit that, let's go math frac. And there it is, 243 out of 32. So I always think it's good to try it with your head first, right? Head calculator, and then go to Texas Instruments calculator. All right, thanks so much. Bye.